So we're going to take a look at the first 30 slides or so of the Mesozoic. I don't want to get too far in because I want to be able to cover dinosaurs with you when I come back, but we're going to go ahead and take a look at some of the basic setup here. So the Mesozoic went from 245 to 66 million years ago. Of course, the Mesozoic follows the extinction, the large extinction event that happens at the end of the Paleozoic. So we don't really see, of course, dinosaurs on day one of the Mesozoic. It takes life quite a long time to rebound after that mass extinction at the end of the Permian. We're going to see two new groups of vertebrates come around, birds and mammals, which birds, of course, are living dinosaurs. And, of course, you are a mammal, so we're going to see them come around as well. Of course, the Mesozoic is three different periods: the Triassic, Jurassic, and the Cretaceous. So the Mesozoic is termed the age of reptiles because we have reptiles on the land, in the sea, and in the air. They are not all dinosaurs. Only dinosaurs really were on the land. We do have one semi-aquatic dinosaur that we know of, but 99.9% of all dinosaurs discovered so far are land-dwelling. They come around in the Triassic, but not till the middle part or latter part of the Triassic. And of course, all non-avian dinosaurs go extinct at the end of the Cretaceous. We're going to see marine reptiles evolve, such as this one you see in the picture here. That's a mosasaur. We're going to see they do start evolving in the Triassic and definitely evolve through the Cretaceous. Our earliest true bird is Archaeopteryx, which comes around in the Jurassic. And our first true mammals occur in the Triassic as well. They're very, very small. Our last major plant advancement is going to happen in the Mesozoic with our flowering plants. Here your book says early Cretaceous, but it's probably more like late Jurassic. So we have to remember our paleogeography setup is we still have Pangaea. So we start the Mesozoic with Pangaea fully formed. So remember, we have Pangaea, we have Panthalassa, which is our ocean, and then of course we have the Tethys Ocean, or the Tethys Seaway here, right, that forms right between Australia and Asia, essentially. In the Mesozoic, Pangaea is going to break up. It doesn't break up 100% in the Mesozoic. We're going to see the latter parts of the breakup is going to happen in the Cenozoic, which is going to be the next section that we cover. But basically from this point on, we're going to watch the continents of Pangaea break apart and move into their spaces where they are today. So the breakup of Pangaea occurs in 4 different stages. Okay, so the first stage is where we're going to see the rifting of North America from Gondwana. So here we have Laurentia. We're going to see this rifting kind of start right here between Laurentia and Africa. So I'm going to put a number 1 there. And really we're going to see this rift first work its way south. Okay, we're going to start to see this breakup here. Remember that the Earth is round, so things don't just separate, they rotate. So what we're going to see is basically the unzippering of Laurentia from Gondwana. But of course, as this occurs, we're going to see lots of faults and volcanism occur up on the East Coast, and we're going to see some remnants of that. But what is pretty neat, as Africa broke apart from Laurentia, this region here of Georgia and the peninsula of Florida actually belongs to this section of Africa over here. So as Africa broke off, that little segment of land got left behind. So if you've ever been to Georgia or the peninsula of Florida, you've actually stood on African crust. Now the second part, the second major rifting that occurs, is going to be between Africa, India, and Antarctica. So here we have a triple junction, and we're going to start to see these continents separate, which this should impress you. India down here is close to the South Pole. So what we're going to see throughout the Mesozoic is India is just going to truck its way northwards so it can eventually collide with Eurasia. Number 3, I'm going to put another number 3 over here. We're going to start to see this Atlantic Rift work its way northward. Okay, so because Laurentia is now going to separate away from Baltica, Baltica is going to rotate this way. to also help close up the Tethys Ocean. So as India trucks its way north, it's going to close the Tethys and collide in with Eurasia. I do want you to notice that at this point, Gondwana is still attached to Laurentia. We're not going to, Greenland is still attached to Laurentia. We're not going to see those two continents separate really until the Cenozoic. Now, those first three happen in the Mesozoic. This last one happens in the Cenozoic. And this last one is probably one of the most important separations of them all. And this is going to be the separation of Antarctica from Australia. And I really say that that's the most important because we're going to see that this is actually what's going to change the climate into the climate that we're in today. So even though it's a continental breakup that's happening very far away, it completely alters the climate. And of course, it takes a long time for Pangaea to break apart. It takes about 150 million years. So we have to remember that the climate is different at this point because there's different factors influencing the climate. We do have to remember that there's different continents over the poles, or lack thereof, over the poles. We're going to see that as we move into the Jurassic and the Cretaceous, this is going to be some of the hottest points in Earth's history, where we're really going to see little to no glaciation at all. Then again, showing you that there's really no continents over the poles. Of course, we're forming a new ocean at this point in time. The Atlantic Ocean is going to form. So we know that living in Louisiana, we know that the Atlantic is just a heat sink. This is why we get all those large hurricanes forming. We're going to develop a new mountain range at this point. We're going to develop the Cordillera, which is the mountain range that runs from California in through Denver. And we're going to, of course, see that that's going to affect our jet stream as it runs across North America and affect the climate. We can also talk about land bridges. This happens as sea level drops. You might have land exposed that connects one continent to another, making it easier for organisms to cross, right? So playing a really important role in migration patterns. But it also can divide ocean currents, which we're going to talk about that when we start to see the connection in the Cenozoic between North America and South America. Changes in snow cover or vegetation cover, right? Pangaea had a lot of glaciers on it. Glaciers reflect sunlight and ultimately make the environment a little bit colder. So as we start to see the loss of those glaciers in the Mesozoic, right, obviously things are going to warm up. These next two, of course, we're going to see a lot of as we see the rifting of Pangaea. Lots of carbon dioxide being tossed up into the atmosphere and particulate matter from volcanic eruptions. That definitely plays into climate change as well. This last one we're going to look at more in the Cenozoic because we're going to see that Earth's orbit around the sun isn't always perfectly elliptical, and the Earth wobbles on its axis, and that in and of itself can also alter the climate. So if we want to sum up, what the Mesozoic climate was like, I wouldn't even say that they were warm. Really, it was hot. If we come and look at this diagram down here, we're going to cover what this means in the next section in the Cenozoic. But basically, oxygen isotopes can help us understand temperature. So you can see that it was from the Triassic to the Cretaceous, things got very, very hot, especially towards the end of the Cretaceous. We're going to see that we're going to have some points where there's very little glaciation at all. And what really impresses me is today we define the tropical zone, if here's the equator, at 30 degrees above and 30 degrees below. Well, during the Jurassic and Cretaceous, we see subtropical plants, which that's mostly what we have in Louisiana, 70 degrees above and 70 below. Okay, that would be like having subtropical plants in Alaska and Siberia, okay, which, northern Alaska is extremely cold, and so is Siberia. So that should really impress you how much warmer the climates were. Well, you might say, yeah, okay, with all the continents have changed position, but really our continents are kind of in the same latitudes. They're just going to rotate around. So it's really a profound difference in the climate.